Okay, so today we'll be discussing about turning effect of the force, right? So we know that forces have many effects. Some of them include that they can lift an object, they can drop, they can pull, they can push, they can change the shape of the object, they can skew an object, right? So changing the shape. What else they can do? They can produce acceleration. In fact, one of the definitions of force is that it is a physical quantity which tends to or actually produces acceleration in an object, right? Force is mass times acceleration, right? Okay, one such effect is the turning effect. Say for example there's a bottle and you want to open the cap of this bottle. What do? You produce a turning effect. Basically, you don't even realize this. You give a couple force. That's called as a couple force. It's like twin forces, right? So twin force is separated by some perpendicular distance. That perpendicular distance is what? It's the diameter of that cap, right? In this case, am I right? No.
Yes, sir, right.
So, for example, this is a bottle. This is the cap of the bottle. So using your one finger, you kind of put a force in this direction, and using your thumb you give another force in the exact opposite direction, and this is the perpendicular distance that I'm talking about, right?
Right, sir.
So this is kind of the situation that we encounter. So this kind of force, they produce a turning effect. Here you have to notice that in the earlier case, in our previous lessons, I gave you an example of this block, and say for example there was this force F in on the right direction, and there is another force equal in magnitude, but it's acting on the opposite direction. What was the net acceleration of this block?
F minus F.
Huh? Very good, Fatima, you're right.
I said F minus F.
F minus F divided by the mass of the block. Fine. So that is what, zero, if both of them are equal, right?
Right, sir.
Okay, because we have already discussed that if there are two forces and they act opposite to each other, the resultant of those two forces is A minus B. If both of them act in the same direction, then it's A plus B. If the direction is not given, it's a general direction, then it is what? Under root of A square plus B square plus 2AB cosine of theta. Am I clear?
Yes, sir.
Okay, fine. But do you notice that there is no perpendicular distance in this case? There is no perpendicular distance between these two forces, right? There is no distance at all. See, one force acts in this direction, the other force acts in this direction, but there is some perpendicular distance between these two forces, right?
Right, sir.
That perpendicular distance is able to produce a turning effect. But do you see the same case here?
No, sir.
There is no perpendicular distance. Hafi, do you get my point?
Yes, ma'am. I mean, sir.
Come on. So
Sorry,
no
sir. Sorry.
perpendicular distance, right? Got my point?
Yes, sir.
So this didn't produce any turning effect. In fact, the acceleration was zero. Fine. But this will definitely produce a turning effect. Imagine there's a door and this is the hinge. The hinges are placed here. So this is one hinge, this is the second hinge, maybe there's a third hinge as well. So this is your axis of rotation, right? This is your axis of rotation. The door rotates about this axis. Now you put the handle here, right? And you push or pull it. Fine, depending upon which way you want to go or which way the door opens. Uh, Now, isn't this the perpendicular distance between your axis of rotation and the point of application of force? Right, Fatima?
Right, sir.
So this, in this case, a couple force or a turning effect will be produced and door will be opened. And we know how door opens, right? It's an arc, right? It's a circular motion, right?
Right, sir. Right.
Okay. So what produces this turning effect? Sorry, there's a quantity, moment of force. Moment of force. Now, what is moment of? What is moment of? Whenever we multiply, we multiply something by distance. We call it the moment of that quantity. Clear? जब भी हम किसी क्वांटिटी को डिस्टेंस से मल्टीप्लाई करते हैं ना, हम कहते हैं वो उसका मूवमेंट बन गया. ठीक. मैं एक एग्जांपल दूंगा. Say for example, I define a quantity mass into distance. ठीक. Now which quantity did I multiply with distance?
Mass.
Mass. So I'll call this quantity, yani mass into distance, call this quantity as moment of mass. Clear?
Yes, sir.
Because I have multiplied mass by distance. So what do you think moment of force would be?
Force times distance.
Very good. There's one more thing that's called as gradient. What's that called as? Gradient is when something is divided by distance. This is not our topic. I'm just saying. Say for example, velocity is divided by distance. So we'll call it velocity gradient. Okay?
Right, sir.
Now say for example, pressure is divided by the distance or the height, whatever. We call it the pressure gradient. And don't we say that the pressure gradient in atmospheric physics, don't we say that the pressure gradient drops as we go up, as we go higher? So the pressure gradient at mountains is low because of the distance. When pressure changes with respect to distance, when velocity changes with respect to distance, we call it the gradient of that quantity. Is it clear?
Yes, sir.
But now we'll focus on moment. So moment of force would be force times. Now this is a very special distance. This is the perpendicular distance. You can have some angle as well, but that will not produce the maximum torque, the maximum rotating force, the maximum turning force, or the maximum turning effect will only be produced if theta is 90 degree. Okay, so it
Okay, sir.
follows the sine function. Does it follow? Do you think it follows the sine function? Sine of 0 is what? Sine of 0 is, guys, what? No answer?
Sine of 0, 7, 0.
Okay. Sine of 45?
1 over root 2.
Sine of 90?
The
1.
sign off.
90 is 1. So it's an increasing function, right? At 90 degree, it has the maximum value. We can say that turning effect has something to do with sine. And in your grade 11, you'll see that that is exactly the case. Okay? Just as we saw that the two vectors, the resultant of the two vectors have an association, have a relationship with cosine of theta, right? Same is the case with sine. I'll not go there right now. Okay. Now, what do you think would be the SI unit of moment of force? The SI unit of moment of force? Hafi, what is moment of force equivalent to?
Wait,
Mass,
yeah, wait. You told us many formulas that remember. Momentum or moment of force?
moment of force.
It was something like. Hang on.
Fatima,
Yes, sir.
what do you think is your answer?
Maybe force
Mm,
into. So does it have force in it, like force into something? Um, Force into distance.
Force into distance. Yes. So what would the SI unit be?
SI unit of momentum. I mean, moment of force.
Mm-hmm.
Um, so force would be newtons. So
What's taking you so long?
wait. Force would be newtons. So distance would be meters. So Newton meters.
Very good. So it's Newton meter. Fatima, didn't I tell you that if you want to know or understand the unit of any physical quantity, just see in which equation the physical quantity lies, or what is the relationship between various physical quantities and the physical quantity that we are talking about. So right now we are talking about the moment of force, and I just told you that moment of force is force multiplied by the perpendicular distance. Right, Fatima?
right, sir.
So what is the SI unit of force? Is that
Newton.
Newton? What is the SI unit of distance?
Meter.
That's meter. So what would the SI unit of moment of force be?
Newton per meter.
Newton meter simply, not per meter, just Newton meter, because this is in a multiplication. If it would have been a division, then it was Newton per meter. But it's force
Okay, sir.
into distance, so it's Newton meter. Correct?
Right, sir. Yes.
Okay, great. You want to copy? Do you check the recordings, by the way?
Yes, sir. Sometimes.
Okay. So they're available. So whenever you feel the need, you can go back to these recordings. Okay.
Okay, sir.
Should I delete this?
Yes, sir.
Now we'll be talking about balanced seesaw. This is basically a case of say for example, there's a seesaw, and this is the pivot. What's pivot? Pivot is around which this whole seesaw will rotate, will move. Okay, got it?
Yes, sir.
Fine. This is called as the beam. And say, for example, there are two people sitting on the two extremes of this beam, of this seesaw. They are called as load. So say, for example, this person is load 1, this person is load 2. Okay?
Okay, sir.
What would be the direction of the weight of this person? Would it be in this direction or in this direction or in this direction or in this direction? Let me call it 1, 2, 3, and 4. In which direction would the weight be acting?
2.
2. Hafi?
In which direction would the weight be active? 2, yes, sir.
2 is this, right?
Yes, sir.
Weight always acts downwards.
Alright.
You jump out of the window, you go in this direction. Try jumping out of the window. Would you go right? Now, we know that weight always acts downwards, right? So this third is the correct direction. Okay?
Yes, sir.
So weight will act downwards. The load will act downwards. Fine? So if it will act downwards, will this load 2, produce clockwise rotation or anti-clockwise rotation in this beam? Would it try to produce clockwise or anti-clockwise uh, rotation in this beam? What do you think?
Clockwise.
Clockwise, yes, exactly. It will try to rotate in this direction. It will try to rotate the seesaw in this direction. This is clockwise. Okay. So load 2 will produce clockwise direction, or at least will try to produce clockwise direction. Right? What would load 2 try to do? It will try to produce anti-clockwise direction. Anti-clockwise rotation. Right?
Right, sir.
Now, if these two movement of forces, now this will produce a movement of force, this will produce a movement of force, right? If those two movement of force due to load 1, if that is equivalent to movement of force due to load 2, then we say that the beam is balanced. So we call it a balanced beam, right?
Right, sir.
So this point P is pivot. What's pivot? Around which the beam rotates. It doesn't have to rotate a complete 360-degree angle, right? That's clear, right?
Yes, sir. Yes, sir.
Fine. Uh, Now, say for example, now this is your axis of rotation, right? Right?
Right, sir.
So I'll measure my distance from the axis of rotation, correct? Now, this person is sitting here, and let's say that it's sitting at a distance of x1 from the pivot or from the axis of rotation, right? And let's say the other person is sitting at a distance of x2 from the load, from the other person, right? The other person is sitting at a distance of x2 from the pivot. Am I clear?
Yes, sir.
Okay. Now, for this beam to be balanced, do you think that what, say for example, the mass of this person is m1 and the mass of this person is m2? Do you think that m2 m1 x1 must be equivalent to m2 x2? Fatima,
Yes, sir.
do you think this is correct?
Wait, sir. Yes, sir, it is.
It's correct, right? Right,
Yes,
it
sir.
is correct. So this is your pivot. Again, this is load 1, this is load 2, this is x1, this is x2, or this is x1 and this is x2, right? Let's say the mass of this body is m, the mass of this body is m1, mass of this body is m2. Fine. This is going to produce a clockwise direction, a clockwise moment of force, and this is going to produce an anti-clockwise moment of force, right? Now, if all the anti-clockwise and clockwise moment of forces are equal, then we'll say that the beam is balanced, right?
Right, sir.
Should I write this sentence? If
You
all
can.
if all the clockwise and the anti-clockwise moment of forces are equal, then we say that the beam is balanced. Will there be any rotation?
No rotation.
No rotation will occur, right? Is this clear, guys? 100%?
Yes, sir. Could you please put the sentence back once again for 1 minute? Okay, so done.
So m1 x1 must be equivalent to m2 x2, right? A safe example, I'll give you a very simple example. There is seesaw. A seesaw is balanced. A seesaw is balanced when a 100 kg boy is sitting on the right side on the right side of the beam at a distance of 1 meter. Fine. And there's another boy. His weight is only 75 kg. So where should the other boy of mass 75 kg sit so that the beam is balanced? Okay, that's already given in the beginning. It's a balanced beam. So where should he sit? What do you think? Where should he sit?
He should sit closer to the pivot.
No. First of all, the answer is not where he should sit. It's a number. What is given, Fatima? Is M1 given? Yes, it's
Yes.
75 kg. Is X1 given? No. We have to calculate where the 75 kg boy should sit, right?
Right.
Is M2 given?
Yes, 100.
100 kg. Is X2 given?
Yes.
1 meter, right?
Yes, sir.
So use this equation. M1 X1 is equivalent to M2 X2. So we need to calculate X1. So X1 will simply be equivalent to M2 X2 upon M1, right? What is M2? 100 multiplied by 1 meter whole divided by M1, that is 75 kg. What's 100 divided by 75?
That's 1.333.
So 1.33 meter. This distance where this 75 kg boy should sit would be more. Now, why it should be more? Can you tell me, Fatima, why it should be more? Can you tell me?
So that equal weight will be put on the beam so it becomes balanced.
Let me give you an example. Did you copy this one?
Yes, sir.
Say for example, I want to put a handle on this door. Don't I put it as far away from the axis of rotation as possible?
Sir,
Do I?
could you repeat?
Yeah. Say for example, there's a door. I want to put a handle on this door. Don't I put this handle as far away from the pivot, from the axis of rotation as possible? As far away as possible,
Yes, sir.
right?
Right.
Why do I do that? Now, say for example, this door can be opened by a moment of force equivalent to 30 Newton meter. How much? Right?
30 Newton meter.
How can I produce a moment of force of 30 Newton meter? How can I do that? Either I apply a force of 30 Newton, right? And place the handle at 1 meter distance. I'll put the handle here, fine, and apply a 30 Newton force. That will produce a 30 Newton meter moment of force. Are you getting my point?
Yes, sir.
I don't think so. Fatima, are you getting my point?
Yes, sir, a little bit.
Hafi, are you getting my point? Okay, she's honest. She says little bit.
Yes,
Hafi,
yes,
you are getting?
yes.
Okay, Fatima, can I also uh, generate a 30 Newton meter force if I apply a 10 Newton force and instead place the handle at 3 meter from the axis of rotation? Will the product still be 30 Newton meter?
I guess.
Right. Now, why do I multiply them? Because moment of force is equivalent to what? Force into
Multiplied by
force arm.
this.
Force into force arm, or the perpendicular distance, right? Whatever you want to call it. Can I also generate a 30 Newton force, 30 Newton meter moment of force by applying a 5 Newton of force and place the handle at 6 meter distance?
Yes, sir.
That's still a 30 Newton meter moment of force, right?
Right, sir.
Among the three, which one would you prefer? One, two, or three? Which case would you prefer?
Any other name?
Any order, any one of them. Is that your answer?
Yes, sir.
Hafi, what's your answer? Hafi, if you're writing something, I'm not able to. Okay, yeah, send it. What's the answer? Fatima, in the first
Yes, sir.
case, do you have to apply a 30 Newton force? Right? Right, Fatima?
Right.
In the second force, you have to apply a force of only 10 Newton.
Right.
In the third case, you only have to apply a force of 5 Newton.
Right.
Why do you want to exhaust yourself and apply a 30 Newton force? Won't you get tired?
Yes, absolutely.
So if we can produce the same effect by a 5 Newton force, why not just use a 5 Newton force and place the handle as far away as possible? 6 meter, let's say. Let's say it's a very huge door. Is it clear?
Yes, sir.
When I asked you 5 minutes before, you said, I guess so. Do you still guess or do you still. Now, are you sure that you got it?
I'm sure.
100%
100%.
or 99.99%?
No, 100.
Okay, mashallah. Then that's fine. Uh, so I think we are ready to move on to the next uh, topic. Take out your book
1 second, sir.
and read the first question you have.
This is chapter.
This is chapter 4.
The first question is choose the correct option in the following statement.
Mm-hmm.
Part A, the moment of a force is bigger if the force is smaller or bigger.
What do you think is the answer? Moment of force, in order to produce more moment of force, should force be larger or smaller?
Larger.
Larger, obviously, because moment of force directly depends on force and also
Yes.
directly depends on distance. More the distance, more the moment of force. More the force, more the moment of force. As we saw in the previous example, more the distance. Say for example, there is a 5 Newton force.
Right, sir.
In the first case, I'm applying it 1 meter away from the pivot. In the next case, I'm applying it 2 meter away from the pivot and 3 meter away from the pivot. So in the first case, I'll be able to produce 5 Newton meter of moment of force. In the second case, I'd be able to produce 10 Newton meter moment of force. In the third, I'd be able to produce 15 Newton meter moment of force. Right?
Right, sir.
I'm writing and I'm not presenting.
Yes.
Clear?
Clear, sir.
Okay. What's the next question? Quickly.
1 second. So part B says the moment of a force is bigger if it acts closer or further from the pivot.
What do you think is the answer?
The moment of force is bigger. If it closer? I don't know.
I'm going to
Further.
further. Like I was just literally just explaining this. This is the distance from the pivot now, right?
Okay, yes, sir.
As it's increasing, the moment of force is increasing.
So
Okay. Next question.
next question says the moment of a force is greater if it acts as 0 degrees, 45 degrees, 90 degrees to the object if it acts on.
So what is the answer?
Greatest. Sorry. It will be 90 degrees.
Is the correct answer because it has to be perpendicular, right?
Right, sir.
Next question.
So the next question is three different forces are pulling on a heavy trapdoor. Which force will have the biggest turning effect? Explain your answer. This is a diagram given.
Okay, there's a diagram given. So the diagram looks like this. This is the trapdoor. This is the hinge, right?
Right, sir.
One force acts in this direction, right?
Sir, it's straight, but yes, okay.
The other one is in this
Okay,
direction. Are there
right,
three
sir.
forces acting?
Yes, three, sir.
Okay, so one is in this direction, one is in this direction, one is in this direction. F1, F2, and F3. Whatever. Which one is F3?
F3 is F3 is F3.
This one is F3?
No,
Did I
yes,
mark
sir.
them correctly?
Yes, sir, you marked them correctly.
Okay, so where would the moment of force be the greatest?
The greatest. F3.
See here, F1, isn't it closer to the pivot, closer to the axis of rotation?
Yes, sir.
This is not going to produce a lot of moment of force. Now, among
Right.
this force and this force, this doesn't act in the perpendicular direction, while as this does.
Yes, so it will
So
be
this
F3.
kind of force will be able to produce the greatest moment of force. Do you now find these questions easy?
Yes, sir.
Is it fun?
I guess.
Not so fun, huh? Okay, fine. Next question.
So the next question says, explain why somebody would use a spanner with a longer
Longer
handle
handle.
if they needed to undo a tight bolt.
For example, this is a bolt. I'm using a spanner. Why do you think a longer spanner would be more effective? A spanner which has a longer handle would be more effective than a spanner with a smaller handle. Why do you think so? Because it needs to rotate this nut to open it, right?
So
So
the
if
big one
it,
will rotate more than the smaller one.
right, because for this x1, x will be more, right?
Right, sir.
So
Right.
obviously this is going to produce more rotational effect. It will be able to produce more turning effect, right?
Yes, sir.
Yeah, I guess you understood the topic very clearly. Alhamdulillah. Okay, next question.
Question number 4 says, A part, explain why a tree is more likely to be blown over a stronger wind. Over in a stronger wind.
This is a tree, right? Why do you think
Right.
it will be blown over more by a stronger wind?
Because more force is applied.
Stronger wind means more force, right? So this is like the pivot. The roots are the pivot, right? It's going
Right.
to rotate in this, I mean, this being the pivot, it's going to rotate around this axis. Either it will go in this direction or it will go in this direction, right? We'll have that to and fro motion, right? Is it clear?
Yes, sir.
Okay, fine. Would taller trees, taller trees be more affected because of this wind, or would the shorter trees be more affected?
I think the
Hmm.
taller one.
The taller ones, obviously, right? Because of their greater distance. This is these roots are the axis of rotation, and this tree is like the beam, right? So this is the pivot, this is the beam, and the wind will produce the load, will produce the force required to rotate it, right? Right,
Right,
Fatima?
sir. Yes, sir. Right.
Okay, next part.
That's the next part. Write down in words the equation for finding the moment of a force about a point, stating carefully the units of each quantity.
Okay, so what is it? What is the equation?
Uh, Sir, it's this. Moment 1 times force 1 is equal to moment 2 times force 2.
It's simply movement of forces, force into perpendicular distance. What's the question again?
The question is write down in words the equation for finding the moment of a force about a point, starting carefully the units of each quantity.
Stating, not starting.
Stating.
So force, that would be Newton, times perpendicular distance from the pivot. The SI unit of that distance would be meter, obviously. So this is your equation in words. The question, the book wanted you to write it in words. This is it. Is it clear, Fatima?
Yes, sir.
Is it clear, Hafi? Hafi?
Yes, sir. Yes, sir. Yes, sir.
If you remember, Hafi, we have already done it in grade 8.
Yes, sir, we have.
Specifically, I'm asking this question to Hafi specifically. There's a reason why. Right,
I
Hafi?
remember no reason.
Oh, don't remember the reason. The reason is that we used to take tuitions last year as well. Fatima joined us this year. Anyway, so yeah. Next question.
Next question. Okay, so it says a bolt is tightened by applying a turning force of 30 Newton to the end of the spanner. That's all it says.
Really?
Yes, sir.
What does it say?
No. Okay, no. A bolt is tightened by applying a turning force of 30 Newton to the end of the spanner.
Uh-huh.
Which of the three distance measurements should you use?
Okay. What are the options? I don't have the book.
50 centimeter, 40 centimeter, and 30.
What is the correct answer? What do you think is the correct answer?
1 second.
So 50 centimeters is how many meters? 50 by 100. 0.5 meters, right?
Right. So
40 centimeter is 40 by 100 meter. 30
0.4.
centimeter is 30 by 100, right? Now, case number 1, you will multiply force into the force arm, perpendicular distance 0.5. 13 to 0.5 is 15 Newton meter. In the second case, the force is still 30, but now the distance is this 40 upon 100. This 0 goes, this 0 and this 0 goes. 4, 3 are 12 Newton meter.
So
In
it will
case
be
number 3,
30.
the force is still 30 and the distance is 30 upon 100. This 0 goes, this 0 and this 0 goes. 3 into 3 is
Right.
9 Newton meter. Which distance you should use, Fatima?
First one.
First one, because it is producing the maximum movement of force.
Right.
Because
So.
obviously the distance is more. It is like using a spanner with a longer handle, right?
Right. So.
Guys, is this clear?
Yes, sir.
100%.
Yes, sir.
Are you tired? Hafi, are you tired?
I'd be lying if I'd say no.
Okay, Fatima, should we stop here?
Yes, sir. If you want, sure. Why not?
Uh, okay, fine. I think this is a lot. What's the next question, Fatima?
The next question is part B of it. Use the distance to calculate the momentum. Momentum. Yeah.
We already did that, right?
Right.
15 Newton meter. Okay. What is the next question?
A uniform meter ruler is balanced
What's a
and
meter ruler?
a ruler which has meters written on it.
No, a ruler is a ruler w- which has a length of 100 centimeter, exactly 1 meter. Have you ever visited? Obviously, you have visited those uh, stores who sell fabric, right?
Yes,
So they have that huge iron rod. That's a
right.
meter scale.
Oh, okay.
So you have a centimeter scale in your geometry box.
Yes, sir.
10 centimeter or 15 centimeter, whatever. So a meter scale is a scale which is exactly 1 meter. Okay?
Okay.
What's
Okay.
the question again?
A uniform meter ruler is balanced and its midpoint, and then it has the values given, and we have to calculate the unknown force F.
So this is a rod, a meter rod. It's balanced exactly at the middle point. Why? Because it's a uniform rod, right? It will be balanced exactly at the center. So this is the zero point 0.5 meter mark or the 50 centimeter mark, right?
So this is a different question, but yeah, okay, right.
Okay. What does the question say now?
We have to find the unknown force.
Okay. Like, do we have any loads here?
Yes, so over there, that's the F is missing, and it is 0.0 meter, and the other side is
We need to
0.8.
calculate this F, and
Yes.
on the right side it is zero point 0.5 meter.
No, 0.07 meter.
0.07 meter, right?
And the other side is 0.18 meter.
It's 0.18 meter,
And the force there is 90 Newton.
90 Newton. This is a very easy question. Fatima, can you do it?
Yes, sir, I'll do it.
See,
1 second.
M1 X1 is M2 X2. Okay, I'll give you some time. Do it yourself. Just want to know your understanding.
So will F be equal to 16.13?
How did you calculate it?
So first I multiplied 0.18 by 90 Newton, which came as 16.2. Then I subtracted it by 0.07, and no, I did it wrong.
Uh-huh. Try again. No problem.
So now I'm confused.
Okay, no problem. Uh, do you think this is X2?
Yes, sir.
So this is like F2. Let's call it F2. This is F1, right? Is this X1? Yes.
Yes, sir.
So F1 X1 is equivalent to F2 X2, right?
Yes, sir.
Now you need to calculate this F2. So F1 X1, this X2 is in multiplication. It goes on the other side, goes to the denominator. You are left with F2, right?
Right, sir.
Now what is F1? It's 90 newtons. What's X1? It's 0.18. What's X2?
0.6.
0.07. That would be your F2. What's 90 into 0.18?
16.2.
68.2.
16.2.
16.2. What's divided by 0.07?
That is 231.42857
Let's just call it 231.4 newton.
So that's why I thought it was wrong because it was a really big number.
Trust yourself, okay?
Okay, sir.
So this is your answer. Is this clear?
Trust,
Yes, sir.
sir.
Yes, darling?
School makes us lose our trust in our answers.
No, darling, you don't have to do that. Just believe in yourself and be confident, right? Have to be confident. Okay, darling?
Right, sir. Okay.
Oh yes, sir.
Okay, then remember me in your prayers. Uh, Take care. We'll see you in the next class. If there are any questions, you can ask me.